Now this can be done in more than one way. So since we haven't done had class, I'm going to work it both ways. Method 1, for me, what I would do is, because that's E and natural log, E undoes natural log, and natural log does E, so natural log happens to be base E. I'm going to take the natural log of both sides. Whatever I do to one side, I must do to the other. Now, properties of exponents allow me to bring this exponent down. That's that whole exponent times the natural log of E is the natural log of 3. Natural log of E is just 1, because that's log base E of E. So that I get that 2x plus 1 equals the natural log of 3. Subtract 1 from both sides. 2x is natural log of 3. Now I'm going to put parentheses in so I can subtract that 1. Now these two don't get combined together because this is inside the logarithm, that's outside the logarithm. Now divide both sides by 2. So you're going to get your final answer of the natural log of 3 minus 1 divided by 2, and that is an exact answer. Now I could choose to do it a different way, and that is to rewrite this guy in logarithmic notation. So this would say that the log, the base is E, it picks up the range, returns it to the domain. Now I'm pretty much where I was before. Log base E is natural log. Taking it of 3, I'll put down parentheses. Now I subtract 1 from both sides. So the natural log of 3 subtract 1 is 2x, or the natural log of 3 subtract 1 divided by 2 is x, and then you notice that indeed we end up in the same place. Doesn't matter which way you write it or work it out. There are other ways as well. With this one, what you want to do is you want to rewrite it in exponential notation. So 2x plus 5 squared is equal to 36. Now some of you multiply that out completely. That'll work too. Or remember, we can use a square root property. So take the square root of both sides. Don't forget the plus or minus. So that 2x plus 5 equals plus or minus 6. 2x equals minus 5 plus or minus 6. Or x equals minus 5 plus or minus 6 divided by 2. So I have two possible answers. X equals minus 5 plus 6 divided by 2, and x equals minus 5 minus 6 divided by 2. Here x equals 1/2. Here x equals negative 11/2. Well, negative 11/2 would make my base negative. And I can't have a negative base, so he's not a candidate. So that's how I end up with the x equal 1/2. In this particular instance, this is a logarithmic equation, so the first thing I do is I use the properties of logs to bring these two together. So log of x times x plus 5 equals 2. Now this log is base 10. Because there's nothing there, it's base 10. So now rewrite it as 10 squared is equal to x times x plus 5. or x squared plus 5x equals 100. And actually it should be 15, not 5. So that x squared plus 15x minus 100 equals 0. This factors into x minus 5 and x plus 20 equals 0. So x is 5, x is negative 20. Now, because I have just the single log of x here, I'd be taking the log of negative 20. Can't take the log of a negative number, so the answer would be x equals 5. Now, there's a couple ways of doing this. Personally, I do it by substitution. So I'm going to let b be equal to 3 to the x, so that b squared is 3 to the 2x. So this turns into b squared minus b minus 72 equals 0. This factors into b minus 9, b plus 8 equals 0, so that b is 9, b is negative 8. Well, b was 3 to the x, so 3 to the x equals 9. 3 to the x equals negative 8. Well, this is an exponential. He's never negative, so that's out of the question. 3 to the x equals 3 to the 2, so this is going to tell me that x equals 2.